Hi guys, welcome back to my channel. Let's inspire technology, and today we are going to continue with where we left off from our lesson 5 practical section. We had the part A where we created all the tables we would need for the part B. So right here, as we're about to head over into our coding section, I want us to prepare our minds. We are just going to write 8 queries to experience how to work with multiple tables. So the first query we are going to write is a query that is going to join the orders table and the customers table on the customer ID column that exists both in the customers table and the orders table. So the first thing we are going to do is to assign the query to query 1, and then we can go ahead and write a query, a multiple line query, so we need it in triple quotes. And so we select all from orders and we join to customers on this column. So here we have our query saved in query 1, and then we are going to use our query data function to retrieve the information we need. So we are going to pass query 1 as an argument to our query data function. But even before we do that, we would want to assign whatever we get from this function to result 1. So here we would want to display a result, so we just type result 1, and there we go. So here we see that the two tables have been joined. The first 5 comes from the orders table, and then the next 4 comes from the customers table. And we see that the two tables have been joined on the customer ID column. Let's head over to our next query. We have 7 more to go. So we're going to do the same thing, query 2. So we are assigning the query to triple quotes. And in our next query, what we want to do is we are going to join our match orders table and our April orders table on the order ID column that appears in both tables. So first of all, we would select all from the match orders and join to April orders. And then on this column we would join them. So the next thing we are going to do is we are going to pull out a result using the query data function, but first we would want to assign that result to result 2, so that will display that in the next line. So here we call the query data function and pass query 2 as an argument to it, and now we can call the result. So there we have it. We joined April orders and March orders table on their order ID column. So where we have 1 in March orders, it would align with the order ID of 1 in April orders, and it flows through like that. So we have 6 more queries to try our hands on today. Query 3. So in this query, we would want to select table 1 and table 2. So we are going to learn how to do a left join. So a left join is when you select all the items in the left table and you join to the right table. So for instance, in table 1 we have some fruits, and in table 2 we have similar fruits like those in table 1, but there are a few different ones. So in this join, we are going to select all the fruits in table 1 and we'll match them to where they have similar fruits in table 2, but in the places where there are no similar fruits, it will be replaced with none. Let's try it out and see. Select all from table 1, left join to table 2. So you're going to join on the fruit name column. We'll use the query data function and assign what we get from there to result 2. So here we have the query data function, and we pass in query 3 as an argument, and then we call result 3. So here we have it. In our left table, all the fruits have been selected. In our right table, the fruits that are different and they don't have similarities in table 1, that is the left table, are replaced with none. So this is how left join works. Let's move on to the next query. In this query, we want to find out some information, okay? So we have two tables, table 1 and table 2. They have some similarities in their full names, but they also have some differences in their full names. Can you guess how we can find the rows or the records in table 1 and table 2 that are different with regards to their full names? Yes, you guessed right. So we are going to use the previous query, that's query 3, and we are just going to add one line to it. So here we realize that there are some records that are replaced with none. So we are going to retrieve the records that are replaced with none using the is now clause. Here we can know the particular rows that have different fruit names. So use a where clause, and there we have it. So we use is now to pull out the records that are not similar in both table 1 and table 2. So we would have to assign the result we will get from the query data function to result 4. And here we have them. Let's move on to query 5. We are going to do a very similar thing here, Okay, so we want the records that are similar in both tables. We're just going to copy this whole thing into an Excel, change every 4 to 5, and then here, instead of is now, we use is not now. So is not now will retrieve all the records that have data types like strings or integers. So we are going to look at the fruit name column, and the fruit name column comprises of strings. So we are going to sift through the fruit name column in table 2 to find out the strings available. That's where we know that there is a matching in table 1 and table 2 with regards to their fruit names. So let's run this query, and here we have it. So here we have the records that appear, and they are similar in both tables with regards to their fruit names. So let's move on to the 6th query. We have 3 more to go. So with query 6, we'd want to learn how to use primary keys and foreign keys to join two tables. Consider we have two tables, that is an author's table and a books table. So for the author's table, the primary key will be the author ID, and in the books table, the foreign key will be the author ID. So the same column that happens to be the primary key in the author's table and the foreign key in the books table, we can join these two tables on that column. Here's how we do it. We select all, from the author's table, then we join to the books table, and then on the author ID column in the author's table, in the books table, the author ID column. We are pulling out the records that are similar in these two columns, which happens to be the same column. So we are just merging the two tables because author ID column in author's table is the same as author ID column in books table. So let's run this query and see how the result is. So here we have it. We have the two tables joined on their author ID column. The 7th query, we would want to learn how to use the cross join. So the cross join is very similar to the Cartesian product, where you multiply all items in one table by all the items in the next table. So the two tables we are going to use here are the animals table and the habitats table. So to make our work simpler, we are going to narrow it down to one column in the animals table and one column in the habitats table. So we'll just go for their names. So let's select the two columns. So the animals name column in the animals table, and then the habitats name column in the habitats table. So we begin with the animals table. So here you cross join with the habitats table. So now let's see how the results will look like. We assign this result to result 7 and we try to work out the result by passing query 7 to the query data function, and then we call result 7. So here we see our 9 animals being cross-joined with our 5 habitats, and since it's a cross-join, the total number of records we have in the result set is a multiplication of the number of elements in the 2 individual columns we had the cross-join on. So the first column we cross-joined was the animal name column, and we had 9 elements there. And then the second column we cross-joined was the habitat name, and we had 5 elements. So the multiplication of 9 and 5 will give us 45. But since our numbering starts with 0, our last number will be 44. There we have it. So now we are on our final query. In our final query, we are going to use the with clause, also known as common table expressions. So here we are going to do something a bit different from what we have been doing so far. We would create temporal tables and use those temporal tables in our query. So with the with clause, we can create our first temporal table, which is match sales. We are done creating our temporal table, but we are getting the data that we would input in this temporal table from an actual table in the database called match orders. In our match orders table, we would want to do some calculation on one of the columns in that table. I'm going to pick up this column, sum the data in that column, assign it a temporal column name, and then we can work with it. So the column we are going to use is the total amount column from the match orders table, which actually exists in the database. So let's just write from match orders. Now from this table, we would want to sum one of its columns. So we go ahead and sum the total amount column. And rename this column to total match. So here we see that match sales is a temporal table and match orders is an actual table in the database. So we make a calculation on match orders by summing its total amount column, and then we rename that sum to a temporal column called total match. So in our query, we are going to work with the temporal table match sales and the temporal column total match. We are going to do this a second time. So here's how we are going to do it. Let's go step by step. So the second thing we will do is, we have mentioned with in the beginning, so we don't have to mention it a second time. So April sales is the temporal table we are creating, and then we want to select the sum of the total amount column and assign it to a temporal column total April. So here we know we are picking it from the actual April orders table. So now down here we write our actual query. All we did at the top was creating temporal tables that do not exist in the database, but with the with clause we can work with these temporal tables and retrieve data from the temporal tables. So here's our actual query. Select total match and total April. from the March sales table and the April sales table. We are calling out for the first temporal column we created, total March, and the second temporal column we created, total April, from the first temporal table we created, that was March sales, and then the second temporal table we created, that was April sales. So here, let's see our results. So there we have it. So guys, thank you for joining me in today's session. It's been amazing to have you as always. And if you haven't subscribed, you can head over and subscribe. Watch out for more contents like these in the future. Until next time, keep on processing, keep on coding, and always strive to be a better version of yourself with each passing day, as we rely on the Lord to be our help. Thank you so much and have an amazing day. Bye bye.